Welcome to mathematics. This is Mangeya, the math eagle. Right. This topic is on statistics, advanced level mathematics, based on the topic the normal distribution. In this topic, you are going to learn about how to derive formulas involved in solving problems involving normal distribution. Then, after watching this video, please subscribe, like, and share this nice powerful video. Mangeya signing in. Alright, the first part, you must be able to know the characteristics of the normal distribution curve. It's more like this. For example, if I can draw it down, it's like this. It's bell-shaped. That's one of the main characteristics. It's bell-shaped. 2, it's symmetrical about the mean. Mean will be standardized to be 0. Then after that, you have to know that the area under this whole graph is actually equals to 1, which means the area on the right side of this 0, which is the standardized value of mean, is actually 0.5, and the area on the right side, on the left side of this 0 is actually 0.5, which means the area under the whole normal distribution curve is 1. Then in addition to that, we have this diagram like this one and this table. This table is actually called the normal distribution table. It's the one that will be used to solve problems involved in normal distribution. Check this graph here. That's the same graph, the normal distribution graph. Then we have Z down here. Z is any value. It takes values from 0. If you can check on this side, that's the Z here, from 0 to 2.9. 2.9, these are the values which Z can be able to take. So from 0 to 2.9. Then we want to see how we can be able to work out some or to derive probabilities first. Like for example here, you can see the area before Z. Let me change my ink here. Before Z, on the left side of Z, the area is actually this one shaded, and is represented by far of Z. Greek letter of the alphabet is far. Far of Z, which is 5. It's far of Z. So that the area on the left side of Z, right? It also represents the probability on the left side of Z. Then after Z, you also have this unshaded area, which means since we say the area under this normal distribution curve is 1, then the area on this side, it will be 1 minus far of Z. In this case, or in conclusion, we can say that the bigger area, this one, is far of Z, and the smaller area is 1 minus far of Z. Let me go back to this page, which means if I can draw here, the bigger area, like even if it's somewhere here, that's my Z here, and 0, and in this case it will be negative since it's on the left side of 0, it's negative. If this bigger area on the right side of Z is actually far of Z, and this smaller area is 1 minus far of Z. So that's what we have to master in this case. Then let me start deriving the formulas one by one. Right, the first one, probability of Z is less than, let me call it A. Given that A is positive, what will be the formula that we are going to use? I can draw my normal distribution graph. Then I put my standardized value of mean, which is 0. Then Z less than A. A is positive. It means it's on the right side of Z. Less than, it means this is the area on the left side of A. This is the area, is the bigger area. So you say far of A. Then we can say done. That's number 1. Solution number 1. Solution number 2. Number 2. Now given that A is negative, Z is less than minus A is negative, it will be 0 here. I put my A on the left side of Z, of 0. That is my standardized value of mean. Less than, it means on the left side of A, of minus A, is a smaller area, then it's supposed to be 1 minus far off. So smaller area is 1 minus far of A, bigger area is far of A. So this one is the area that is needed. It also represents probability. It's 1 minus far of A. Since the area on this left side of minus A, on the right side of minus A is actually far of A. Area under the normal distribution curve is actually equals to 1. Number 3 formula, probability of Z is less than, let me use now greater than, given that we are using less than already done, greater than A, given that A is positive, you draw it like this, then 0, A positive is on the right side of 0, which is this area on the right side, that's the greater than area from A going this side. Right, it's a smaller area. What I'm supposed to do is 1 minus far off. Number 4, probability of Z is greater than minus A, given that A is now negative. Then you draw your graph. It will be 0 here. Minus A is on the left side of 0. Then this will be the area greater than on the right side of A. Is this bigger area, which means it's far off A. Then done. Next, number 4, I think, or 5, probability of Z. Let me put lies between two positive numbers. We have A, Z lies between A and B, like this. I have to draw my normal distribution curve like this. Then after that, I put my 0, A and B. These are two positive values. Z lies between two positive numbers. It will be this area here. That's the area. So to find this area, what I'm supposed to do, you say the area before B minus the area on the left side of A. Then we can be able to find this area. That's primary level, right? So its area before B, it will be this whole area up to this side, which means it's bigger area on the left side of B. It will be far of B. Then if we consider A, it's also the bigger area on the left side of A. It's far of A. It's minus far of A. Far of B minus far of A. Then done. Next, number 6. Probability of Z lies between a negative and a positive. A negative and a negative value. Then from this you can draw your graph here. Then you put your 0 symmetrical about the mean 0. You put your minus B here. Then minus A on this side. The area is in between. Is this one. Right, to find the area, you say the area that is after A on the right side of A minus the area on the right side of B. Right side of A is actually the bigger area, which means you say far off A minus for B is also the bigger area, then it will be far of B. Please don't put those negative numbers. They just show you that the negatives are on the left side of 0. But when writing, it's just far of A, not far of minus A. Far of A minus far of B. Then we can say done. Then next, number 7, probability of Z lies between a positive and a negative value. Minus A and B, it will be like this. Minus A on the left side of 0, then B on the right side of 0. If you are to find this one or change the area, is this area. That's the area being represented in this case, is between minus A and B. How can we find the area like this, right? You say the area before on the left side of B, which is bigger area, that is far of B, minus the area on the left side of A, That is a smaller area for A is 1 minus far of A, like this. Then you say far of B, remove the bracket, minus 1 plus far of A. Then you can say far of B plus far of A, then minus 1. This one will be the probability. You find it this way. Right, let me put 2 more. Right, let me find this part. Right, then the other one, number 9, I think probability of Z lies between minus A and A. These are two same values, right? So if it's like this, then you just draw your graph, your diagram, then you put your 0. This side is minus A, this side is A. Then you shade, this one is the area that we need, that we are looking for. We just use the same concept. It's area before A minus area before minus A. Area on the left side of A minus area on the left side of minus A. These are also probabilities. Take note. Left side of A is far of A since it's bigger area, minus left side of minus A is actually smaller area, so it's 1 minus far of A. Remove your brackets. Is far of A minus 1 plus far of A. Then you can see we have far of A plus far of A, which is 2 far of A minus 1. That's the probability. Then you can say done. This, take note, this one is the same as writing it like the magnitude or modulus. Probability, that's the modulus of Z is less than A. Is still the same as writing it this way. Modulus less than A is the same as Z lies between minus A and A. Right, moving down. Right, questions. Question number 1. If Z is equal to, in this case, this sign means varies as or is normally distributed. Z is normally distributed in this case. So Z follows a normal distribution with mean 0 is actually the standardized value of mean, which is only represented by mu. That's the mean of this distribution. Then 1 is the variance. Variance 1. A standard deviation, which is usually represented by sigma squared, is also 1. Standard deviation is square root of variance. That one I'm sure you know it. A standard deviation is the square root of variance. And sigma squared is actually equal to standard variance. Right, so Z follows a normal distribution with mean 0 and variance 1. Part A, find the probability that Z is less than 0.874. You draw your graph. That's for part A. 0 mean, then less than is 0.874. It's on the left side of, on the right side of 0. Less than, it means the area before this one. This is the area. Right, based on our formulas, is it the bigger area or the smaller area? If you can check, is this bigger area? Bigger area, you just say far of 0.874. Remember, it's far of A, which is equals to, right, on your normal distribution tables now, you have to check 0.8 under 7, then difference 4. 0.8 under 7, common difference 4. This one, the normal distribution table, 0.8 under 7, difference 4. 0.8, you check these values here. 0.8 under 7, 7 is this value. That's 0.8 under 7, 7 is on this side, and 0.8 is on this side. Then 0.7 under 0.8 under 7 is this value, 0.8078. Let me write it down. 0.8078. 0.8078. Then common difference, what's the common difference here? Is 4. you check common difference is this section from this side going this side. These are the common difference from 1 up to 9. So when the common difference of 4 is somewhere here, this line, so it will be, this number is 11. Always you add the common difference. So you have to add 11, but 11 you add on these last digits. So you add here, 8 plus 1 is 9, 7 plus 1 is 8, 0, 8, 0 point. So this will be your final answer. That's the probability in this case. Next, probability of z greater than minus 0.874, like this. Draw your graph like this. 0 minus is on the left side of 0, it's minus 0.874, greater than is this area on the right side of this negative value. It's a bigger area, right? So bigger area, what do you say? You just say far of A. It will be far of 0.874. You do the same thing. Check 0.8 under 7, common difference 4. You get the same result here. 0.8 under 7, common difference 4. So your answer will be 0.8089. It's still the same as this one, right? It's still the same as this one. You still have to add the common difference 4. Right, next, number part C is now greater than. If it's greater than, probability of z greater than 0.874, 0.874, right? You draw your graph here. It will be like this. 0 greater than, it's on this side. 0.874 greater than, it means is this area. As you can see, is the smaller area. Smaller area, what do you say? You say 1 minus far off. So it will be equal to 1 minus far of 0.874. If we can, right, so 1 minus far of 0.874, you can check it's still the same as this one. So which means you're supposed to get 0.8089. Then if you can subtract here, what can you get? Let me use my calculator. 1 minus 0.8089, you get change 0.1911. 0.1911. That will be your final probability. Right, next question. You still have one more here. Right, you have this one. It's now less than minus 0.874. 0.874 less than, z is less than minus 0.874. Right, you still draw your graph. 0 standardized value of mean minus 0.874, then less than is this area. This area is actually 1 minus far of A, so it will be 1 minus far of 0.874. If you can check, it's still the same as this one. So it will give you the same result. Moving on to the next question. We have this one. Z follows, if Z follows a normal distribution with mean 0 and variance 1, find A, the probability that Z is greater than 1.8. Z greater than 1.8, right? You draw your graph here. 0, 1.8 is somewhere here. It's on the right side of 0. Greater than, you shade this area. That's the greater than side on the right side. Then this area is the smaller area, so it will be 1 minus far of A, which means 1 minus far of 1.8. 1 minus, you check on your normal distribution table, 1.8 under 0. So it's 1.8 under 0. 1.8 under 0 is this value, 0.9641. 0.9641. 0.9641, 0.9641. Then if you can subtract 1 minus 0.9641, what do you get? 0.0359. 0.0359, like this. Then moving on, next, let me check which one. Let me choose here. Question number C. Let me pick C. Probability of Z greater than minus 2.46. You draw, that's question number part C. 0 here, minus 2.46, then greater than is this area here on the right side of minus 2.46. If you can see here, the area is actually the bigger area, which means you say far off A, so it will be far off 2.46. So on your table you have to find 2.4 under 6. 2.4 under 6 here. Where is 2.4? Is this one under 6, right? So this one starts at 0, 1, 2, 3, 4, 5, 6. So 2.4 you can say 0, 1, 2, 3, 4, 5, 6. So is this one 2.4 under 6, 0.9931, 0.9931, 9931. So that will be the final answer. Then you can say done. Then let me do the last question. Question number H. Probability of Z lies between is less than 0.725 minus 0.725. Is this one, right? You draw your graph here. It's 0 minus 0.725 on the left side of 0. Less than, it means this area, that's the less than side. Then the smaller area, what do you say? You say 1 minus far of A, far of 0.725, like this. Then it will be 1 minus far of 0.725. You find 0.7 under 2, 0.7 under 2, then common difference 5. 0.7 under 2, common difference 5. 0.7, where are you? 0.7 is here. Under 5, you say 0, 1, 2, 3, 4, 5. So is this value 0.7734. 0. So let me work it out here. 0.7734. Then you have to add the common difference. You have to add the common difference in this case. 0.7734. Common difference is what? It's 5. Common difference is 5. So I find where there's 5 here. The same is 1, 2, 3, 4, 5. So it will be 15. Common difference, they start at 1. Take note. So it will be 1, 2, 3, 4, 5. So 5 will be 15. You have to add 15 here. 4 plus 5 is 9. Then 4, 7, 7, 0 point. It will be 0.7749. If you can subtract from 1 here, you get your final answer. 1 minus 0.7749. It will be 0.2251. 0.2251. Then you can say done. Right, moving on to the next question. Question number 3. Find the probability that Z lies between 0.829 and 1.834. Why? Same concept, same rule applies for the first part. You draw, you put your 0 here, then 0.829 and 1.834. Both are positive, so it will be this area. Remember, if both are positive, it will be far of B minus far of A, but we can work it out here. You say here, area that is on the left side of 0 or the bigger number, 1.834, minus area on the left side of the smaller number. So it will be far of 1.834 minus far of 0.829. Let's find the probabilities. 1.8 under 3 difference 4. 1.8 under 3 common difference 4. 1.8 under 3. 1.8, where are you? Is here. Under 3. 0, 1, 2, 3 is this one. 0.9664. 0.9664. Let me write 0.9664. Then you have to add the common difference, right? So difference is 4. Let's find 4 here. 0.8 under common difference 4 is 1, 2, 3, 4. It's 11. So you have to add 11 on the common difference. You get it's 5 here. 7, 6, 9, 0. 0.9675. 0.9675 minus, let me also work out the other one. 0.8 under 2 common difference 9. 0.8 under 2 common difference 9 is 0.8 under 2 common difference 9. So for 1.8, the first one, it was 1.8 under 3 common difference 4. 1.8 under 3, 0, 1, 2, 3. So it's supposed to add common difference 4 is supposed to be here. 1, 2, 3, 4. So it's supposed to be 3, not 11. So this one is 3, not 11 here. It's supposed to be 3, which means this value will actually be wrong. It will be 3. If we can add is 7 here. 6, 6, 9, 0 point. Then this value, it will be equals to 0.9667 minus. Now 0.8 under 2, difference 9. 0.8 under 2, 0, 1, 2 is this one. Difference 9. 9, we have to add 1, 2, 3, 4, 5, 6, 7, 8, 9. We have to add 25. So add 25 to 0.7939. 0.7939. You add 25 here. Then it will be, add always the common difference. 4 carry 1 is 6, 9, 7, 0 point. So it will be 0.7964. Then you can subtract here 0.9667 minus 0.7964. 0.7964, you get 0.171703. So this will be your final answer. Then next part B, probability of z lies between minus 2.56 and 0.134. Minus 2.56, z lies between minus 2.56 and 0.134. Right, this one, you draw your, it's negative and positive, remember. So if it's negative and positive, you can just use our formulas up there. It's minus 2.56 and 0.134. Is between these two values, so you share the area in between. That's the area. So probability of z lies between a positive and a negative value. If you can check up here, positive and negative value. What did we say here? We said positive and negative is here or down here. Positive and negative is far of A, far of B plus far of A minus 1, far of B plus far of A minus 1. So these are the formula that you just have to use, right? These are the formula that you have to use. Far of A, far of B plus far of A minus 1. So it will be far of B minus far of A which is far of 0.134, plus far of A is far of 2.56, then minus 1. Right here you check 0.1 under 3, common difference 4, 0.1 under 3, common difference 4, 0.1 under 3 is here, common difference 4 is 16. So it's 0.5517, 0.5517, 0.5517 plus 16. If you can add here, let me check again. Yes, it's 16. Then if you can add here, what you get? 7 plus is 3. Carry 1 is 3 here. 0.5533. You write 0.5533 plus. Now check 2.5 under 6. 2.5 under 6. Where are you? 2.5 is here under 6. 0, 1, 2, 3, 4, 5, 6. 0.9948, 0.9948, 9948, then minus 1. Then if you can punch in your calculator, 0.5533 plus 0.9948 minus 1, you get 0.5481. 0.5481. That will be your final answer. You can say done. Right, then next question. Right, if the letter is unknown, then how can you find the letter in this case? Now we're finding A. Initially, we're trying to find probabilities. Now we're trying to find the letter A. You draw first question number A, probability of Z less than A. You draw your normal distribution graph like this. Then you put your 0. Now, A can be negative or A can be positive. It's try and error. You have to check. If A is positive, for example, it will be on this side. You check. Then you can put your A this side. So if A is positive, you say Z less than minus A is this side, this area. So it means A is supposed to be far off A, right? Supposed to be far off A, which means we can say far off A is equals to 0.9738. 0.9738. But now in this case, this number must be the number that is found in the tables, inside the tables. Our table, if you can check here, it starts at 0.5. It's here 0.5 and ends at 0.9986. This one, the last number. So this number must be in this range from 0.5 to 0.9986, right? Take note of that. Then let me go back. Is this number in the range? Yes, it's there. What is the probability? Is found inside the table. So you say far of A is 0.9738. This 0.9738, you find it inside the table. 0.9738, you find 0.97, 0.97, then 38, 9744 is here. It's actually here. It's here. It's here. So you check these numbers on this side. It's 1.9 under what? 1.9 under 0, 1, 2, 3, 4. 1.9 under 4. That will be your A. So A is 1.9 under 4. That will be the value of A. You can say done. Next, probability of Z is less than A is equal to 0.2435. You draw your graph. First assume A to be positive first. Use try and error. If A is positive, then it means A is somewhere here. Less than A, it means is this area. Is this area. That's less than A. Right? If you are finding this area is the bigger area, it will be far of A is equals to 0.2435. Right? Now this number must be the number that is in the table, inside the table, right? But remember, our table, it starts at 0.5. It starts at 0.5 here. So which means this number 0.2 is below 0.5. So it now cancels out the concept that A is negative, A is positive. Now we can conclude A is actually negative, because we are supposed to say 1 minus far off. So A is negative, which means if we can put our A on this side as minus A, it will be less than, it means is this area. Is the smaller area, it will be 1 minus far of A is equal to 0.2435. Why? Because you have to subtract this one from 1, so that you can get a number that is in the range from 0.5. 0.24 is less than 0.5, so it's not in the range, it's out of the range, it's not in the tables. Right, from this you can say 1 minus far of, let me say 1 minus 0.2435 is equals far of A. Then you subtract from 1 minus 0.2435, you get 0.7565. It will be 1 minus, actually let me just say far of A is equals to 0.7565. 0.7565. Now we check this number in the tables. You say A will be minus. Now you check 0.7565 inside the tables. 7565. You check 0.7565. 7565. We have 7580. Right, this one is more than, is greater than 7565, so you don't take it, you just leave it. Then you have 7549. This is the one that you take, so you just take a number that is before 7565, right? So it's 7549, that's the closest number, so it will be 0.6 under 9. 0.6 under 9. Then what will be the common difference? 0.6 under 9 is this one. So to get 65 here, what we're supposed to add here? We're supposed to add, if we can say 65 minus 49 is 16. 16, which means 16 is here, is under, is common difference 5. So you write your common difference 5. Then you can say this will be your answer. That's your A, done. Next part question. Probability of Z is greater than 0.82. Z greater than 0.82. Probability of Z greater than 0.82. The same rule or concept applies. Right, you say you draw your graph and assume A to be positive first. A to be positive first. So it will be 0 here, A positive, is greater than A is equals to 0.82. Probability of Z greater than A, probability of Z greater than A here is 0.82. Greater than A is equals to 0.82. Find the bracket. Then you assume A to be positive first. Right, if A is positive greater than, it means this area. So I'm supposed to say 1 minus far of A is equals to 0.82. If we can say 1 minus far of A, it means far of A will be 1 minus 0.82. 0.82. If you can subtract here 1 minus 0.82, you get 0.18 is far of A. So far of A is 0.18. Then this number must be there inside the table. But if you can check our numbers, our probabilities, they actually start at 0.5, which means this one is not inside. So A is not positive, which means A is actually negative. We have to put A on the other side. So A is negative, it's minus A on this side. Then greater than, it will be on this side. So it will be far of A, what is bigger area, is equal to 0.82, like this. Then after that, you can check 0.82 inside the tables, please. 0.82, right? This one is 0.8212. 8212 is here, but one 0.82 straight. So this one is more than 0.82. You check a number that is before that one. So it will be 0.8186. It will be 0.9 under 1. 0.9 under 1 is minus 0.9. 0.9 under 1. Then common difference on this 0.8186 to be 0.82. What are supposed to add here? You have to add, you just say 86 to be 200 here is 200 minus 186, you get 14. So you're supposed to add 14 to 0.8186 to be 0.82. Add 14, where is your 14 here? Right, you can see that there's 15 and 13. You take the smaller one, you take 13, you don't take 15 because it will be more than 0.82. So you take 13, 13 is under 1 here, it's 5. So it will be 5. Then we can say done. That will be your final answer. Take note of that. Right, then you also have these ones. You can try them, or you can try one here. In this case, first question, question number 1. Question number 1. Then the other ones you can try as an exercise. Probability of Z is less than S is equal to 0.6700. So remember, I said S can be negative or can be positive. Right? So the other trick that you have to know is, if this number is more than 0.5, is 0.5 and above, it's a number that is inside the tables, right? So if it's inside the tables, we are not supposed to say far 1 minus far of, we're supposed to say far of S is equal to 0.6700. If it's inside the tables, you're supposed to say far of S is equal to, so to say far of S is supposed to be negative or positive. In this case, it's supposed to be, because it's the bigger area. If you can put your S positive, it's less than, so it's the bigger area. So you can say S is positive actually. So you can conclude based on that. Let me check number 2. It's still the same. Number 3 is still the same. Number D still the same. Then let me take E. Probability of Z is greater than S is equals to 0.4052. Probability of Z is greater than S is equal to 0.4052. 052. Right, like this one. Right, since this number is not in the tables, it means you are supposed to say, that's the trick, you are supposed to say 1 minus far of S. So that if you can subtract it from 1, it will be a number that is inside the table, right? So for us to say 1 minus far of S, it means S is supposed to be positive or negative. You check using your graph 0. If S is positive, it means it's here. Greater than is this side. Yes, so S will be, it will be greater than. Greater than is 1 minus 4. So S is positive. Then you can use this format, right? Right, check number, this one, or probability of Z is less than U is equals to, probability of Z is less than U is equal to 0.0468. 0.0468. Right, like this, we can say, right, this one 0.0468 is not in the tables, so it's supposed to say 1 minus far of U is equal to 0.0468. To say 1 minus far off is supposed to be, what is our u? If we take u as positive here, it's less than. Less than is supposed to be this one. So it means this one will be far off u. So it will be wrong. So 1 minus far of u is this side, so it's the greater than side. So u is supposed to be actually on the negative side, right? So you say here, so u, we conclude that u is actually, was is less than, is negative. Our u is negative, so that we can say less than, it will be 1 minus far of u. So u is negative. You work out to find the answer, so u will be negative. So with this, then let me check one more missing. This one, for example, minus u and u, you check our formulas, you can say 2 far of u minus 1 based on our formulas that we have initially designed. Then based on this one is the same as this. Probability of the magnitude or modulus of z is less than v. It means z lies between minus v and v. That's the probability is equal 0.50. It will be exactly as part S. Right. So with this, I can say Mangeya signing out. Thank you.